class about context. Okay, so let's start, guys. Okay, hope my screen is visible to everyone. So, guys, the topic of the day is high availability on Cisco ASA, right? So that is the topic of the day. So the first of all, we need to understand what is the meaning of high availability. Any one of you know about this? What is high availability and how we can achieve that on Cisco device or firewall? Okay, guys. So high availability is actually to provide the redundancy to the network or the links, right? So this is used to provide redundancy to network components, right? So how we can provide that? So there are multiple ways actually. If we talk about from the point of view of Cisco firewall, okay, suppose we have here one user, and user is connected with switch. Okay, okay. So the topic of the day is high availability on Cisco firewall. So usually high availability can be provided with multiple ways. Okay, and how we can provide, there are multiple ways. So first of all, we need to understand what is the requirement of high availability. Suppose in this network I'm connected with a switch and the end user, and the switch is connected with our firewall, and the firewall is connected with internet. So that means this user is trying to communicate with internet through the firewall. So we have these IPs, right? 10.10 is the gateway on the firewall. This is the WAN interface IP, and here we have internet connection. So that means the host traffic is coming to the firewall, and firewall is inspecting the traffic and then forward to the internet, right? As per the policy. But here we have few things that is not good. So that means if this link have some issue, okay, maybe the link is not good, or maybe there is any problem with your fiber connection, maybe this is fiber or ethernet. So if there is any problem with this physical media, so that means this LAN is now completely isolated, right? So there is no communication with outside world, right? So that is the challenge in the network, and to prevent such type of problems in network, and we have multiple solutions, right? So now we have here one topic or concept that is providing us high availability, or there are two topics actually on firewall. So the first topic is failover that we are going to be discuss. So failover is like this concept or this technology This feature is used on Cisco ASA to provide high availability. Okay, so this provide high availability into like we can get two type of high availability things. The first, if we talk about, we have link high availability. Okay, and the second we have node high availability, guys. The second is node high availability. So the first thing we need to understand, what is the difference between link high availability and the node high availability. Any one of you have idea about that? So let me explain you. The link high availability, in which we are going to be provide the physical redundancy on the network component, right? So what we are going to be provide here, provide the physical redundancy to the component, right? So that we are trying to achieve here using this. Okay, how? Let me explain you. So suppose in the same scenario, now I have end user here. This end user is going to be connect with my network switch, and here I have Cisco firewall. So here we have two physical links connected from switch to firewall, and the second link is connected with my internet, right? And now you can say these two links are connected on firewall, but we are not going to be configure these physical links for IP address and all these things. So that means, okay, the first point is here, if in this case, if the first link is not working, so we have at least second link on the firewall, so that is giving me physical level redundancy, right? So that means if one link is not working, at least we have second link, or you can say the redundant link. So I'm using the second link as here redundant link, right? So that means we can use the redundant link that can give us high availability in the problem of the first link, right? So what, how we are going to be achieve redundant link configuration on the firewall? So that means we have to be configure these two physical links as your one redundant link. Okay, so these are going to be part of one redundant link. So this redundant link is like your virtual interface or like logical interface. That is going to be logical interface on firewall. And on this logical interface, we are going to be configure everything, whatever is required. Like I'm going to be configure the IP address, okay? And I'm going to be configure the security level, or the interface is part of inside network. So the name, if IP address configuration and the security level configuration is inside the redundant link, okay? So in which we are not going to be configure the physical links. What we are not going to be do here, we will not use the physical links for IP address configuration, right? So what we are going to be use here, we are going to be use the redundant link, okay? The configuration will be part of redundant link, okay? So that configuration is inside the redundant link now, okay? Like whatever I'm going to be configure, that is my under the redundant link. So maybe this is my gateway, okay? And I need to define the name if interface, but maybe the name if interface is inside for me, right? So that means we have now two physical links, okay? and those two physical links are now working as a logical link for me on firewall. So that is logical link, that is kind of logical link here. Okay, so this is from this is on ASA end, guys. But if you talk about here on switch level, so switch level still you have two separate interface, those are maybe part of the same VLAN, so there is nothing like redundancy. Like yeah, normal switch use these to interface as your host ports here, like VLAN 10 and VLAN 10. Okay, but if you ask if we have gateway on the redundant interface on firewall, so which interface is going to be used, this interface or this interface or both? So in that case guys, here is the switch, and the switch is connected with two links to firewall, and here is internet media, right? So in that case, this is now your redundant interface. Okay, so we have redundant interface that have IP address 10.1.1.10/24. But if I talk about switch side, these are two normal interface part of VLAN 10. Okay, now in the case of redundant, ASA use one interface as active, like we have to interface gig 0 by 0 and gig 0 by 1, right? So in the case of this, firewall can use only one interface as active and other interface as standby. So there is no such election criteria in the case of redundancy. So you can say in those physical interfaces, only one interface will become the active interface. Okay, and other one is as standby. Okay, so that means one interface is going to become your active and the second is standby interface. Okay, and in that case only active is going to be forward the traffic, standby is just waiting for the role. That means if active interface goes down, and then standby will become the next active interface. Okay, standby will become the next active interface, and there is no election criteria, any interface can become the active, so that we cannot decide. Now, there is one point. If this is clear to everyone, now let's come on one point, how the communication is going on. If we have here end user, and end user is trying to be communicate. So as we know always, like end user have 10.1 IP, the redundant is your gateway. Okay. And here we have public IP, and this is your like server or internet, right? So that means whenever 10.1 is trying to communicate with your 20.2, so the first time always host generate the ARP request, as you know, right? Host will generate the ARP request for the gateway MAC address. So in that case, ARP request will come on the interface of switch, right? On the interface of switch, and switch will do the broadcast, as we know the behavior of the switch. So broadcast will reach to this interface and this interface. Just an example, let understand or assume here this interface is your active interface. So upper interface is active and this interface is standby interface. Okay, in the redundant configuration. So now what we can do, so if this is active and standby, so ARP will come on both interface, guys, and in that case ASA is going to be reply only from the active interface, right? So you can see the next point is only the active interface provides the ARP reply. Okay, and active for the gateway IP address, gateway IP address and MAC. That means active interface provides the ARP reply. So that means which are received on the standby interface, that is going to be drop, and ASA will just reply from the upper. And even there is no chance of loop because that how configured the device. Okay. Okay. So that is the traffic flow in the case of redundancy. Okay. So now, if we talk about, we are just getting the redundant. Now, that is about the redundant, how we configure the redundant on this side and how that is working. The second point is about the, okay, now we discussed about link high availability. So link high availability actually giving you 2 points or two things. And what is that? The first thing is it's giving you like redundant configuration, right? The first is first is redundant interface, so that we configure. And the second is what we can do. We can do the port channel, guys. What we can do? Port channel. So that means we did in redundant interface configuration. So in redundant interface configuration, the downstream device, which is switch in our case, so the downstream switch is not much, you can say, smart device. Why? That means downstream switch is only using these links as standby links, like one as who is forwarding data to the active interface, and the second is not forwarding data to the standby, because ARP will only reply from this interface. So this interface is going to be learn the MAC address of gateway. So there is no MAC address of gateway on this interface. So every time if traffic will come on the switch will use the same link which is connected with active interface. So that is maybe my active interface. Okay, if you see here, see the traffic is coming here. So this interface learn the MAC address. So just assume we have gateway 10.1.1.10 and MAC address is like A0, right? So this is the MAC address. So when user is trying to reach like MAC address 01, uh, trying to send data to broadcast to switch will send broadcast on the both interface. But here active interface is going to be reply. So reply will be from the source MAC address 0A of the firewall active interface, and the destination is 01 MAC address at layer 2. So when this traffic is coming on the switch is going to be learn the source MAC address, which is the gateway MAC address 0A. So 0 is now learn on this interface, not on that interface. So that means every time the traffic is coming on the switch, so if the destination MAC address is 0A, the destination MAC address is 0A, source is the host MAC address 01, sending data to 0A. So at layer 2, switch check, okay, MAC address belongs to this interface, which is learned here. So send the traffic from upper interface. So that means in the case of redundant, I'm just getting redundancy. I'm not getting the utilization of both links at the same time. Okay. So in that case, what we can do, we can use the second option, that is port channel. That is port channel, guys. Okay. So the second option says if we can't use both links together, so we can bundle them. We can bundle them on switch level and the firewall level. Okay, and the every configuration will be part of port channel, similar like redundant. Okay, Now, let me explain you the second point. So the second point, I'm just giving you the brief of it. Port channel, okay. So in port channel, we will bundle the both links on firewall, okay. And configuration will be under the port channel interface, right? So that we will do. And see, switch switch is going to be connect with the firewall. And now what I'm going to do, I'm going to create here port channel now. So like my port channel is 1, okay. And here also I'm going to bundle the both of the links. So what we are trying to do, on switch level we are making the switch a smart device. So that means now my configuration is under the port channel firewall. So gateway is this, okay. In that case, firewall can utilize both the ports. Firewall can utilize both the ports. So traffic will come maybe from the upper link or maybe from the down link. Why? Because it's depend on the switch. What load balancing algorithm is used on the switch for port channel configuration, right? So by default, maybe it can be the source MAC address, it can be the destination, or we can change source and destination. So accordingly, we can use any one of the interface to transmit the data, or it can be the both of the interface for different users as per load balancing. So now we are utilizing both the links. We are utilizing both the links at the same time, right? So that is under the port channel. That is under the port channel. So this is the difference, guys. Is that clear to everyone? Guys, Daniel, Kenel, Siva, Vidya. Okay, all good. So now let's discuss the second thing. So we just discussed here about the link high availability, right? So we are giving high availability for the link. But what is the second point? What about the device? Suppose if this device is not anymore, maybe the device is down because of the power loss or maybe because of some short circuit inside it, right? So in that case, what we have? What option do we have? So the second option is node high availability, right? So node high availability means if there is node down in network, then second node can be used as gateway device, right? So we can use the second node as our gateway device if there is any failure with this first one, right? Okay. Daniel, could you mute please yourself? Okay. Thank you. If you have any doubt, guys, you can ask, please. Okay. Now, how we get the node high availability? Let's discuss that point. Node high availability. The second thing is we need multiple appliances to achieve this task. So that means if I want to achieve high availability, so like at least I need two firewall. At least I need two firewalls. Those are going to be provide high availability in the network, right? And what is the second thing? So failover feature, we can configure failover feature, right? On the firewall. So failover feature provides the node high availability, right? Provides the node high availability, node HA. So we can say HA in the real environment, high availability, okay? But there are few prerequisites whenever you are going to be configure node high availability in the network. So you need to make sure about few things like what are the physical requirement of the device in that case, and what is the logical or you can say the software requirements or you can say the prerequisites, right? So these you have to be make sure about that before going to be configure this feature on the firewall. Before going to be configure the this feature on the firewall, guys. Okay. So let me explain you about which features are required on the firewall to achieve the node high availability. So first of all, let's discuss about the hardware requirements. So in hardware requirement, the first thing is platform, the hardware platform, like the series of the device. Okay, platform must be same. What is the meaning of platform must be same? The hardware series of firewall, what series we are using, so make sure other firewall also belong to the same series. Suppose I'm using here 15x series, so maybe other firewall also must use the same series. It can't like you can't make one firewall have two like RAM size 2 GB and one have 1 GB. So that is not working. Okay, so you have to be make sure what is the size of the RAM on one firewall. So that must be same on other firewall also. Otherwise, during the configuration, you will see the hardware compatibility issue on both firewall. Okay, and the third type is the type of the interface. Okay, types of interface, what type of interface we are using on the firewall. Maybe I'm using the gig interface on firewall, or maybe I'm using the ETH interface on the firewall. Okay, and the second thing, number of interface, number of interface, so those must be same. Those must be same. That means if I'm using gig interface on my firewall to configure the failover, or if I'm using ethernet, so on both device they must use the same type of interface. Like if one firewall have ethernet interfaces and the second one is using gig interfaces, so that is not compatible, right? And even the number of interface, like how many number of interface we are using in one module, so those must be same, the module wise interface. Okay, and after that we have here one or more hardware, that is flash. So flash size also must be same. This must be same. Flash means which storage keep the ios file of the device. So that means like my operating system of the firewall is existing in the flash. Okay, so that must be same on both firewalls. Okay, so you have to be make sure about that. And the last point, okay, what is the last point, guys? So if you have any additional module, hardware module on the firewall, that must be exist on the other component as well. Okay, if there is any additional, okay, if there is any additional hardware module on one ASA, that must be present on other ASA also. So that means if I'm using suppose okay, IPS module, like IPS intrusion prevention system module. So under the firewall you can also install that module. So if one firewall have IPS module, that must be exist on other as well. Okay. So if this module with ASA1, then it must be installed with other ASA also. So that means we have to make sure if I'm using any particular module for more security features on the firewall, okay, so that time you have to be installed on both firewalls together. Because if one firewall have module and that is your like active during the traffic forwarding, so if that is down, so if other firewall don't have, it will make the problem, it will make the problem, right? So that's why we have to make sure about these things, okay, the small things. And if this is clear, what is the second point? So these are the hardware requirements of the firewall. So you have to make sure everything is compatible. And the next one is the software requirement. Like if I'm talking about the operating system of the firewall, what should be there? So under the software requirement, in software, first of all is operating system version of the firewall. Okay. Operating system version must be same on both ASA. Okay, so that must be same whatever operating system you are using. Suppose you are using version 7.4.2. So this must be same on both firewall, not only on one. Okay, major and the minor. And the next one is mode must be same. Like the firewall must be configured in the same mode. Okay, firewall mode. What I meaning by firewall mode, maybe firewall is your routed mode, or maybe it's into transparent mode. Okay, so that must be same on both. So that means if one firewall have routed mode and one have transparent, even that is not going to be work. Okay, so that should be same. And now next point is, guys, the modes of the firewall, right? Modes means we have also like single mode of firewall and multi-mode, right? So that means like we discussed in the last class, we covered the context feature on the firewall. So context feature says you can use the firewall in multi-mode, okay, and you can create multiple context. Normally firewall into your single mode, right? So that means on both firewalls you can use single mode either, or you can use multi-mode, but you can't use one firewall with single mode, one with multi-mode. Okay. And the next point is, if you are using any connect VPN package, okay, VPN and client package actually, client profiles must be available on both ASAs. Okay, so you have to make sure not only on one. This should be available on both ASA. This should be available on both ASA. Actually, this is used during the any connect VPN, that is remote access VPN. Okay, and this should be installed manually if that is not available. So that we need to be installed manually on both firewalls. Okay, and one point that is belong to VPN section, so we will discuss in the VPN about it. Okay, but this is kind of a software that is exist on firewall also. Whenever any user is going to be connect with the firewall in a remote access VPN, so that software must be visible and package must be visible on both firewalls, not only on single. Is that clear to everyone? So these are the requirements on hardware and the software of the firewalls. Okay, so now let's discuss the how the node high availability works, guys. So let me make a network diagram here. So this is kind of network connectivity for us. Okay, so in this network connectivity, so I am using here, this is my end user. Here we have 10.10 IP, here we have 10.11 IP, here we have 20.10, here we have 20.11. Okay, and this is my server which is with 20.2 IP address, guys. So in that case, what I'm trying to achieve here, if my this firewall is not working, so I have at least another firewall who will provide the high availability to me, who will provide the high availability to the network, right? Now this failover features works with virtual firewall also. Okay, this feature works with virtual firewalls also. So we have virtual, that time also we can use the failover between the firewalls, and in which we have to define what we have to do. We need to define primary and secondary firewall roles. So that means I have to define manually one firewall as my primary and one as my secondary firewall. Okay, but there is one point, that is active, and so only one is going to become active. Okay, only one firewall will become the active firewall for data forwarding. Data forwarding, that means only one firewall can forward the data in that case, but it's not mandatory only primary is going to become the active or only secondary is going to become the active. That means any firewall can become the active. Okay, so we will discuss the scenarios when the firewall is going to become active, okay, and when secondary is going, sorry, yeah, secondary is going to become the active. Okay, so we can define manually the roles is like primary and secondary usually. So by default, failover is disabled on firewalls, okay, and the role is secondary. The role is secondary by default. Failover is off on ASA, and the role is, or you can see the state is actually, guys, not the role. State is secondary. Okay. So now in this case, so there is now one point, like just try to understand. This is my primary and this is my secondary, right? So that means suppose who is going to become active and what will be the gateway address and MAC address in that case. Any idea about that? So guys, do you know about HSRP? Any idea about HSRP? Okay, let me explain you. HSRP normally work with virtual IP address if you remember, right? So like this is IP address on ASA1 interface, this IP address is on your ASA2 interface. But we don't have any virtual IP concept in the case of failover. So now which firewall is going to become your active, that IP address is going to be used as your gateway IP and the MAC address. Suppose we configured first failover on this ASA, so that is going to become active for me. Okay, if this is active, second one is like standby for me. Okay, second is standby. So now the active router IP address is 10.10 and the MAC address is for 0A. So this is my gateway IP address and this is the MAC address. Okay, and in that case, if this user is requesting the ARP, if this user is forwarding ARP request, so that should be forward on both of firewalls. But this firewall is as your standby. Okay, so that is not going to be reply. And now this firewall is going to be reply with gateway IP 10.10 and the MAC address is 0A. So user get to know, okay, my gateway is 10.10 because we configured on that, and MAC address is 0A. The gateway MAC address is 0A. So that means all the traffic will pass through the ASA1. All the traffic will pass through the ASA1, right? But if my firewall is no more in the network due to failover, so in that case, and host know the MAC address is 0A and this is my gateway IP address. So we are not going to be change gateway IP address or MAC address. So whatever IP address and the MAC address is chosen as gateway from the active router. So ASA becomes the active router, right? At the first, so it uses IP address and MAC address of its own. So now this router is secondary. So secondary is going to become now active. Okay, standby to active. So this active is also going to be used the same MAC address and IP address as your gateway. So it's not going to be use its own IP address. Why? Because first, which firewall is chosen as active. So failover start using that firewall IP address, okay, and the MAC address as gateway information. So now this is going to be used for the lifetime in the failover concept between these two firewalls. Between these two firewalls. I guess this concern is clear to everyone, or is it? Is there any doubt, guys? Everyone? Daniel, is it clear? Kenel, Siva, Vidya? Okay, great. Now, what is next? So we need to understand few more points here before start the configuration. So I just explained about the primary and the secondary, okay? But what can be the variant here that we can understand? Okay, let me explain. Okay, so the first of all, suppose we have here primary. So I will configure with IP address. This is my primary, and this is my secondary firewall, right? Primary and secondary is role, but active and standby can be according to the situation. And what are the situation? So the first of all, suppose I am going to be configure this device. So this device is going to be boot in the network, and during the boot, this device not found any active device or any active firewall in HSR, sorry, in your failover. So that is going to become the active. If primary is going to be boot and during the boot it will not find anyone as active available device in the network, so primary will become active in the failover, okay? And at that point, if secondary is also going to be boot after this primary, okay, secondary is also going to be check is there any active device in the network, and if this is going to be find okay there is active, so that time it's going to become the standby because active is available in the network. So secondary will become the standby, okay? So this is my case number 1. And now the case number 2 is if I'm going to boot both of them at the same time simultaneously. So at that time, if I'm going to be boot both of them, so in that case, that is okay. This is going to become active, and secondary is going to become the standby. So if you will boot both of firewalls together, so in that case, primary always become the active and secondary always become the standby. So that is already defined, okay? If both are going to be boot. And in the third case, guys, in the third case, so if secondary is going to be boot, and if there is no active in the network, so then this is going to become the active firewall, guys. This is going to become the active firewall. Is that clear to everyone? Okay. So if this is clear, let me tell you about. Just a minute. Mm, okay. Just a minute. Okay, guys. So there are some prerequisites. Okay, so we will go through this document. So here we have some prerequisites, system requirements for that. And if you see the failover overview, configuring failover required two identical ASs connected to each other through the dedicated failover link. So there is one more link that we need to know. And what is that, guys? That is known as failover link actually. So when we connect the firewalls together, right? Here we have these two firewalls. So those firewall must connect with each other directly, or maybe between they have any layer 2 device. So if I have this ASA, and this is your ASA number 2, so they are going to be connected with one dedicated link, like this is my gig 0 by 2 interface. So this interface is going to be configured as your failover link. So this failover link actually share the failover information, who is the primary and who is the secondary. And that information exchange between these two firewalls over every 1 second. So that means in 1 second they are transmitting the packet to each other, and they are using here one protocol. And what is the name of the protocol? The protocol is SCPS. Okay, this is the protocol, and protocol number is, what is the protocol number? Protocol number is 105. Okay, so this protocol is working to share the failover information between the firewalls, and that packet is sent after every 1 second to each other through this link. If this link is not anymore, so suppose if this link is not anymore between them, so that is going to become the active firewall, and that is also going to become the active firewall. So maybe in that case, some users are getting this IP address as gateway, which IP address 10.10/24 and 0 a MAC address as gateway, okay, from this active device. And some of users are getting this IP address as gateway and this MAC address. So that will make the problem in future, okay. Now, if this is clear, now we have few things here that we can discuss. So the we need to configure one failover dedicated link, okay, that is going to be operationally as a state link. So that is also known as state link sometime, okay. So failover link actually share the just failover configuration through the protocol, and state link sends more information that we will discuss later on, okay. And now ASA support two failover methods that we have not discussed yet. One, both firewalls can be configured in active role, okay, or both can be configured in standby and active role, okay. So what is active? Active failover. One unit is going to become active with pass the traffic, and standby unit does not actively pass the traffic, because standby is going to be just monitor it, right? What's going in the network, right? And when failover happens, active unit fails the standby unit, which then become active unit, right? Okay. And after that, we have to understand here hardware requirements, which we already discussed. If you check, so the two units in the failover configuration must, like, both must have same module, or like have same number and type of interfaces, same module installed if they have any module, right? And RAM must be installed with the same size. And if you check, If you are using unit with different flash size in your failover configuration, make sure unit with the smaller flash has enough space to accommodate the software image file and the configuration file. Okay, as if it does not, configuration synchronization from the unit with the larger flash memory to the unit with the smaller will fail. That means the configuration sync will fail during between the firewalls, because the unit which have small size maybe face the challenge, right? Just a minute. Okay, and after that we have some software requirements for that. And what are the software requirements? Like, those must be in same mode, routed or transparent, okay, in same context, single or multi. And after that we have some other things like same major version and minor version. Major version is like your 8 version, right? And minor is like 3. Okay, so however you can temporarily use different version of the software during an upgrade process. For an example, we can upgrade one unit with this version and the second with this one, and failover remain active, but recommended version is we must use the same. Okay, like their minor version, like it's a 3.1 something, it's 3.2, so those must be same. Okay, and the last thing is we discussed about the any connect image. So if you have any SSL VPN connections, so the image and the profile, client profile must be same. Okay, and later on you need licenses as well. You need to make sure that two units in failover configure do not need to have identical license, so license must be your same in that case. Okay, and after that we have here failover link, guys. What is failover link? Okay, see, the two units in failover pair constantly communicate over the failover link to determine the operating status of each other. So failover link is actually a dedicated link, so they can check what's going on, they are alive or not. So you can say the failover link is working as your keep alive link. This is working as your keep alive link, right? Okay, so that is about the failover. I hope there is no any doubt till now. Anyone? Guys, all good? Okay. So if everything is good, let's start with the configuration. Okay. So the first of all, I'm going to start with the configuration. Just a minute, I need to make sure one thing. So I will try first with redundant, okay, the link high availability. But I need to make sure one thing. Interface redundant. Yeah, we can configure here. Okay, so let me connect. Okay. So you can do with this virtual image ASA failover task. So first of all, I'm going to make here ASAV image. Second, we need IOL image, a layer 2 device that is our switch. Okay. And let me use two routers. So choose the layer 3 image and these are the two routers. Okay, let's connect here. And the second is here. So I'm using here two physical links between switch to firewall. Okay.
Sir, why you are using two links in between switch and firewall?
Just to show you how we can configure link high availability on firewall. I will use both methods. One is the redundant and the second is port channel, right?
Okay.
Just a minute. Okay.
Why don't you use two firewall?
I will use two firewalls. First of all, I will show you the redundancy for the link. Then I
Okay.
will come to failover, right?
All right.
Because if you remember, I discussed first about the link redundancy. And even you can give the link redundancy during the failover also, right?
Okay.
So we are using here inside, and it's 10.10/24. Okay, this configuration is here. And here is outside, and here is 20 network. So this is our 10.1 and 20.2. This is client, which is 10.1, and here is server. And this is 20.2, guys. Okay. Now let's start the configuration. So I'm starting with the configuration of router. R1, and then we have R2 and firewall. Okay. So R1 is the client device which have IP address of, and interface is 0 by 0 connected with the switch. IP address is 10.1/24, right? And we need to give the default route towards the firewall, 10.10, right? And now the next one is R2. Configuration host name is R2. Interface is it 0 by 0. No shutdown. IP address 20.1.1.2. Okay. And now give the route so it can reach to the 10. Wait a minute. Uh,
Mazio.
yes, yes. Am I audible? Okay. Line VT by 0 to 4. Transport input all. No login. What's wrong? Default route is again not right. Okay. Okay. So we are done configuration on R2 and now let's start on ISA. So first of all, let's give the host name to the firewall, that is ASA. Give me a minute, guys. Okay. So now let's start the configuration of interface. So first of all, I'm going to configure the gig 0 by 2 interface, guys. Now shut down it and name it at outside interface because this is our outside interface. And here configure the IP address. IP address is 20.10, right? And slash 24, right? So we did on this interface. And now the next to interface, we are not going to be configured on physical interface on firewall as we discussed. We are going to be configured on redundant interface. So the first thing you need to know, shut down the interface one by one. Okay. After that, we need to bundle the interface. So I'm moving into the, okay, not bundle the interface, we need to use the redundant. So I will give the port number here like 1. Okay. And I will give here member interface. So member interface is like my gig interface 0 by 0, right? And member interface is 0 by 1. Okay. And now I will give here name if is inside, right? So security level is 100 and here we have to give the IP address. IP address is 10.1.10 slash 24, right? Now if you check show interface IP brief on firewall, so we have IP here on WAN interface which is connected with my R2, and the second is given here on your redundant interface which is 10.10, right? So the IP address is given here properly. Now we can check show interface redundant one. Wait a minute.